Okay, hello everybody. Nice to see you all here. And if you remember a few years ago when ChatGPT came out, I don't know if you did this, I definitely did this. I started experimenting creating a UI. I was just trying to get the model to come up with some code and see how far it could go. And I did this ChatGPT experiment where I entered a very comprehensive prompt. I just said, build a loading component. Make no mistakes. Actually, the prompt was a little bit more elaborate. You know, make a React component, and I tried to do. Those days we were prompt engineers, so like build it with this animation, 3 pixels, whatever, replying code blocks, make no mistakes, and it came up with this, which is nothing fancy. It works. And in those days, you had to copy and paste this and put it into your editor. You know, it feels like, wow, savages. Those days were like difficult things, those days, where you had to copy and paste. You had to ask ChatGPT, please reply in code blocks, otherwise it will not work. So this was vibe coding before vibe coding was cool. We're just trying to build some UI and push the models to see what they could do. And it was a very simple example. But something clicked for me when I tried this. And I was like, hold on a second. This is good. It was not just an example. I shipped it. It was good enough. But the most important thing was, it was fast. I could create UI, I could create components, I could create code very fast. And even in those days where you had to copy and paste, it was decently fast. Fast forward to last year, and maybe a lot of you last year during the Christmas break started experimenting with something like Opus and started creating things. And as everybody, the first thing that you do is you try to create your blog. I mean, people did even more impressive things, but I was like, I should just rewrite my blog. So I just gave Opus some instructions, and it created something really good. But then I was like, I'm missing a feature. I'm wondering if I can just create another very comprehensive prompt and ask Claude to build me a search bar. And actually, that's the whole prompt. I didn't put anything else. I just built a search bar, make no mistakes. Now, actually, this time was like, build a search bar, I'm feeling lucky, go for it. And it blew my mind. It was like, OK, it took like a few seconds, and I came up with this, which is a nice blurred animation with the keyboard navigation, with a list with all the blog posts. And I was like, wow, this is very good with just one prompt. Now, we went from, hey, ChatGPT and these large language models can create really decent code, to, hey, the code works, to, this is elegant and it's good code, to now, mind blown. Everything works out of the box. So I just came to the realization that LLMs are better at front-end coding than me. And it was a very hard realization where, hold on a second, I'm not that good anymore. These things are very good and are better than me. And you know what? I don't mind it. I don't mind that they are very good, because now you can do way more things. Now, here's the question to the audience. So, if LLMs are now so good at building components, building UI, why are we still stuck in this old paradigm of static UI, mostly static components? This is the question, and another question I could put is, where is my Jarvis? Where is my floating UI appearing from nowhere? Definitely, the LLMs are capable of doing something like this. Where is this? So here's the presentation, and here's what I pretend I forgot to introduce myself. And I say, that my name is Ruben Casas. I'm a staff vibe engineer at Postman. I have a lot of hobbies. This is part of the website I built for when I was vibe coding with Claude. And today we're going to explore these different levels of generative UI. We want to see where can we go with generative UI, and we're going to go from the different levels. Level 1, static components. Level 2, where we inject some declarative UI, and then finally generative UI components. So let's start with the news. If you haven't realized, we have a new computer. And it's not that computer. Anybody bought a Mac Mini during the last few weeks? 2 or 3 people. I didn't buy one, but it's not this computer. It's not a Mac Mini computer. LLMs are a new computer, a new type of computer. And there is a really interesting quote from Karpathy, who has a very, very interesting talk I definitely recommend to watch about software is changing. And he gave this talk in June last year, which feels like 100 years in LLMs, in AI terms. But he said, but even back then, when you talk to ChatGPT or LLMs, it feels like you are like interacting with like the terminal. It's like the operating system and the interface is going via text. So it's just text. We are just interacting directly with this machine, with this operating system. And it feels like back in the 70s, where we had this, the GUI was not invented, and we had these text-only interactions with the computer. And that was the computer of the 70s. Now we have a new computer now, which are the large language models. So we're still trying to figure out what is the interface for AI. And this is a very interesting question, because we have not figured it out completely yet. We're still asking the question. And people say, it doesn't have to be chat. And people say chat is not the UI, it's not the final interface, which I agree to an extent. But if it's not chat, then what is the interface that we're looking for? What is that operating system that we're looking for? One thing for sure is, I hope, or my hope is that this new UI, I hope it's not static. And I hope it's not what we have today. Because if you think about it, the current input method of input text and static outputs, they're mostly like the peripherals, when you connect your keyboard, but you don't have a mouse. Like you're still like typing, you don't have a mouse. The next level is, okay, you don't have a mouse, you have a mouse now, maybe voice is going to become important, but then you don't have a word processor. Like you don't have a canvas like Microsoft Word or Excel to interact with the UI. That hasn't been invented yet. And then finally, the internet, or like sharing things or showcasing the output of the LLMs, is still quite not there yet. Like we don't have a printer. We cannot put these things in the real world and showcase them in monitors and appearing from holograms or whatever. So we are not there yet, but I want to show you what we're doing today and how we're solving this today. So patterns are already emerging in terms of how we're solving the problem with UI. And these patterns are mainly injecting AI into existing user interfaces. And this is probably, it looks like old now, but when Cursor did this, was quite revolutionary. We've been used to working with an IDE where you just code and type text, but then Cursor put the agent or the chat interface inside Cursor, inside your IDE, and now we have a new way of interacting with UI. So we are injecting the AI into the UI, and everybody started copying that, and now everybody has a chatbot or a chat interface into their UI. The other thing that is happening is we've been looking at MCP apps and ChatGPT apps is the other way around, which is we are injecting UI into the chatbot or the AI agent. And this form, the LLM just loads third-party widgets or UI, and that's what we've been looking at. The interesting thing about this is it maps one-to-one to what I call the 2 types of UI, which is the first-party UI, where you as a builder, if you're building a website or an agentic user experience, you have full control, and you can just create everything like Cursor did. They own the client, they just put their chat in there, and you own the host, you have control, you can build anything. You have full control of building any UI that you like. On the third-party scenario, of course, we don't control the client, We don't control ChatGPT, we don't control Claude or any of the agents or Goose. And we are kind of injecting our experiences in there. Now, these two are different ways that this could go. At the moment, I don't know which one is the better one. I mean, the users will tell us. But it is two different outcomes. One where we have a super app, where everybody's going to use one super app, and everything else is going to connect to them. So that's one scenario. And the other scenario is we're still building in individual specialized applications that use LLMs to provide a better functionality. Examples of first party and third party, I mean, A2, AUI, they do something similar. On the third party, we have seen MCP UI, MCP apps, and ChatGPT apps SDK, which I'm going to go beyond in a second. Now, this is how you inject UI, but now what type of UI you are injecting in these cases? So the first type of UI that people are injecting, which is a very simple one, is we're just doing what we've been doing for so long, which is creating static components. Static components are very simple. It's just basically an orchestrator. The agent says, I want to render some UI depending on the context or the parameters, etc. It sometimes takes the form of a tool call. And then after that tool call, with all the data, it renders the component client-side. It's a very simple system, very similar to the previous system, which was a server-client interaction, where the client requests something from the server returns some data, the client renders the UI. This is an example from AG UI, where they have a front-end tool call, which is basically saying, when you made this tool call, get the data, and I'm going to return a predefined UI component, which in this case is this weather widget, and I'm going to pass all the props that the LLM is creating, and then inject them into there. Another example I love to showcase, because it's a very interesting example, is Goose Auto Visualizer. And I worked on a similar feature as well. And I remember when I was looking at Auto Visualizer from Goose, is that you can take any data source and then ask Goose to create visualization for it. So it will create a chart, map, Sankey, whatever type of visualization you want from any source of data. And you look at that and like, okay, this is really cool. It's generating some really complex UI. But behind the scenes, this follows the same pattern as the ones before, which is a static component. So you only have a predefined number of visualizations that you support. So you cannot only support bar charts and so on. There are like 7, 8 different types of visualizations. The interesting thing about Goose is they decided to use this on top of MCP UI or MCP apps now, which was an interesting choice because Goose controlled the client and the server. But what I put emphasis here is it doesn't matter if it's first-party or third-party UI. The fact that we are building different types of UI and generative UI, it doesn't matter on the distribution. We are focusing on how do we build this UI? How do we get this UI? There is the demo from Goose. I mean, I can show it all. I'm not sure if the internet is going to work. Let's see. I have another demo. But this is, for example, the visualization with the map. I just gave it a massive large data set, and then Goose just produces a nice map, which is very, very impressive. Now, the question is this generative UI? Let's see. The next type is declarative UI. This is a different one that has started to gain a lot of popularity, where you still have a set of static components, and then you have some language descriptor, which is usually JSON or something that you can describe the UI with. And then you have this layout rendering engine that produces the components. But hold on a second. That looks very familiar. I don't know if you have seen before something like this before, but back a few years ago, Netflix and a few others made this concept very popular with the personalization engine, and they called it server-driven UI, where you inject some logic into the back end, and it produces a JSON file for your personalization, and then there is a rendering engine that produces some UI. So when you go to the Netflix homepage, that UI is kind of assembled and created on the fly, given some business logic that they inject on the server. Now, the difference between this and what we are doing with generative declarative UI is instead of that server and the personalization engine that Netflix has with a lot of complex logic, is the agent who decides what type of UI is going to be presented to you. So the agent is generating that JSON and is trained on the structure on what that JSON should look like. Then the rest is the same. We have a layout engine, we have a rendering engine that translates that JSON into components. I have a little demo here in terms of something that I found really, really cool with JSON Render, which is by Vercel. They created this playground where you can describe what you want, and you can visualize what the agent is generating. So let's create a search box. And if you see, it has generated a really nice looking component. And on the left, you can see the JSON that has generated to produce that output. Now, the LLM is creating the JSON. It is not creating the component directly. It's creating the representation of that component. And we have this nice looking UI. Now, you might notice that the UI looks very similar to Chat-CN or the Vercel components look like. And it's because this line here, it says it's constrained to your catalog of components that you define. Now, let me just get back to my presentation. The question is this generative UI? We still stuck with this static definition of components. They're still static components. So we are not actually generating the UI on the fly, or the LLMs are actually not generating that UI. So finally, this is where generative components, I probably need a better name, like generative UI, generative components, is where there is a big opportunity here. The model is very good at writing front-end. We saw that. It's better at writing front-end code than me. It's better at writing React than me. Why we just don't let the LLM write the components at runtime on demand? What could possibly go wrong? The only thing is, if you don't trust third-party code, then of course you shouldn't trust the code generated by LLMs. Not just because of security, also because of quality. So one thing that is very important here is you need a sandbox. You need a way of sandboxing and rendering this in a safe space. You need to give the LLM a place where they can operate and create the components. And guess what? There is a really interesting sandbox out there that is very useful and that has a lot of the security things built in already, which is MCP apps. So that's why generative UI, in terms of the distribution, we already have the problem solved of the sandboxing, where we can just let the model generate some HTML, CSS, and JavaScript, and then just render it, because we already kind of have that security. And this type of generative UI, as we said, applies to both first party and third party. I'm not saying that generative UI is only for MCP apps. And I think this is where I disagree with the Copilot Kit guys. They have a slide where they say that generative UI is MCP apps. I disagree, because it's a completely different thing. It's nothing to do with first party or third party UI. It's about letting the model generate that UI on the fly. So here is where we come to the demo, and where we come to figure out if the Wi-Fi is going to work. So let's see. All right, so here I have Postman. And Postman is like the MCP inspector. We also provide the option for you to test your MCP apps. And the way I want to test this very simple application, generative UI, is just to get the weather and give me a joke together. For the weather in Paris, and let's say I want this to look like Windows 95, because I like retro. And it's going to take a while, so I'm going to also try it on Goose. So show me the weather in London. Any style preference? Anything? Sorry? Art Deco, okay. Let's see. This one is already finished, so you can see this is my weather widget. Now, this is a tool call that is not just giving me the weather. This weather is coming from the weather API, but the LLM not just generated the UI, it also generated some text, like a little joke saying, you know, forget your umbrella and your jacket, damn chilly and regretful. Nice. Sounds like, oh, this is Paris. I thought it was London. So this is the UI that has been generated on the fly, and we have, hopefully Goose is also working. There we go. So Goose is also showing me the temperature in London. It's a bit chillier. It's in February, damp, chilly, and in a puddle in a okay, interesting. But how does this work? Is generating the UI and it's sending currently just raw HTML, CSS, and JavaScript. That's what we're getting right now. This is a very, very simple example. Of course, LLMs are way more powerful than just HTML, CSS, and JavaScript. They can generate React, can generate anything. So this was the demo. Let me just get back to the presentation, and then we do the conclusion. And so this is the diagram of how the demo currently works. And we have the agent. In this case, will be Goose or Postman. Well, an agent, an LLM agent, that will be performing a tool call. That tool call internally calls another agent. And this agent, in the case of the weather example, has a system prompt that says, you know, get me the weather, use this second tool call. So this agent has another tool call that gets the weather from the weather API, gets the results, combines them, generates the HTML, CSS, JavaScript, and then finally sends it to the MCP client, in this case, Goose or Postman. So we have this model where we have an agent by a tool call that calls another agent, and then finally generates the UI. Now the question is, can we simplify this? There is something I've been experimenting with. There is an idea, it's theoretical. I haven't really had a chance to experiment with it, which is, what if we just remove that agent and we use something like sampling with tools, where you have the main agent that has an LLM, and then we can just create a sampling request to get that agent to generate the UI and then just render it to the client. Theoretically, this works. My only concern will be the non-determinism of the host LLM, because I don't know what LLM or model they are using. But it's just a food for thought there. If you want to explore this, it's an interesting optimization that could be done there. So conclusion is, what is generative UI? Is that generative UI? I don't want to sound like the guy like, well, actually, it's not actually generative UI. To be honest, we can call it, if we want to call it generative UI, and if we go to the definition, it has to be, the LLM has to be generating the components. But to be honest, the other types of generative UI, the static one, the declarative one, are probably more powerful in terms of consistency and what you can get out of it. So if you want to know what are these types, just ask yourself, what is the LLM rendering? So if the LLM is just rendering parameters and data, then we just have static generative UI, where you have your components and you have the client, and you just generate this with the data parameters. If the LLM is generating instead JSON with the descriptors, then we have something like the JSON renderer from Vercel, where it's not actually creating the components, it's creating the JSON and the representation. And finally, my demo, which was, well, the components actually, the LLM is actually rendering UI and CSS, JS, React, you name it. Okay, so I think we are at time, and feel free to ask some questions. Follow me on X. I'm trying to write down all of these things I think about generative UI. And thank you very much. Okay.
So I got the internet back, so I can actually ask you the question from the crowd. The first one is about, obviously, generative UI is a big paradigm shift. And intuitively, the person asking the question feels that it doesn't apply to most apps. So the question for you is like, what percentage of apps do you think could ultimately leverage this new generative AI? Is it for everyone or?
So definitely not, and definitely depends on the use case, and also depends on consistency. What I wanted to highlight here is we have not figured this out. There is a huge opportunity. The technology is there, but we have not figured this out. Because if you say, oh, everything should be generated on the fly, first of all, it's expensive. Second, it's probably a little bit slower. And third, it's also going to cause a little bit of inconsistencies because you need to give the LLM a little bit more guidance. But those constraints should not stop us from looking at what could be done ahead. So this is an opportunity that is there. We don't know what it's going to look like when models are more advanced, more like faster, more consistent. But you can still experiment with the other types. So if you want more, like if you want speed, if you want more reliability and consistency, then the model where you can create the JSON descriptors with like the JSON renderer from Vercel or A2 UI is a very good model as well, because it gives you like a balance between consistency and being dynamic and letting the LLM be creative as well, because the LLM can be creative with the JSON, but the output is a little bit more static and more deterministic.
Thank you. And we have a second question. What do you think about anthropic imaging, the generative UI runtime they presented where user agent on UI triggers UI generation?
I haven't tried it. Is that Anthropic?
Me neither.
No, what is it?
Anthropic imaging.
It's like an image model. I cannot comment because I haven't tried. I'm sorry, but I'm pretty sure people can. Labs will be experimenting with this. I mean, Google is experimenting with the A2 UI protocol, and
so we have time for one more question, perhaps. Well, there's plenty of questions. So two more questions.
First of all, great talk, Ruben. Thank you.
Thank you.
I have a question with MCP. Our idea was to allow brands to also convey their branding and identity to the chat. Right? This is the idea behind third-party UI. It's not just building generic widgets. It's also sending the booking experience and the Airbnb experience and the Ticketmaster experience to the chat. So I want to ask, like, from your opinion, if you're looking at the spectrum of static, declarative, generative, where do you see this branding fit in? I mean, we can't have the booking UI to, like you said, have the booking button be on the right side on one hand and the left side tomorrow. So how do you look at it?
Yeah, that's an awesome question. I think this goes into the consistency spectrum. So there are other ways we've been exploring, like the Shopify, the remote DOM was an interesting one. But if you think about it, remote DOM is also similar mapping from the LLM declaration of like the descriptor, in this case could be JSON, to a component that's already predefined, that you have the CSS tokens, that you give a little bit more determinism, which is important for branding. So if branding is important, definitely generative UI, like full generative UI is not going to work because user experience is another problem. Like users are not recognize your brand, and second, the button might be in a place that is awkward. So all of these learnings that we had with user experience and accessibility have to be taken into consideration. So where it fits in the scale, I will be looking at the middle with the declarative way, because it gives you that balance. It's not fully static. It's not just components that you build once and they are the same. You can have a little bit more dynamism with the LLM creating the JSON, but the output, which is what we care about, the consistency on the branding, the colors, the positions, potentially, with the layout, it is predefined, is more reliable for end users. Thanks, Liat.
I had a question. Well, last question. So here we talked a lot about the output of the interface, and I feel one of the big change is the input. You know, the fact that now multimodal models allows you as a user to interact with your computer, not only with voice or keyboard or mouse, but multiple in a multimodal way. And I feel generative UI has a role to play on how to convey the information in the context and the ways the user has done the inputs. So I was wondering if you had any view on the input also aspect of the UI.
This is a great question because it's probably going to be another talk. But if you split this into two sections, one is the input, as you mentioned, where UI is changing, where the layers are collapsing, and where before we had a lot of UI needed for you to input things into the machine. Now it's easier, sometimes, probably not faster, but it's easier to interact with multimodals, voice or text, to ask the agent to do something for you. Now, once that is done, this is the next level, which is I either have two options. I can collaborate with the agent and enter a collaboration slash whiteboard, not whiteboard, like a canvas, where we can collaborate on that UI and change it together. Or is the output, which is just show me what you did and display it. So in conclusion here is the input is where most of the UI is going to go away, because we are not going to be building click here, button, drop-down menu, and just for the agent to take an action. We will just be saying it, but then the collaboration after that, the follow-up, and the artifact that is produced at the end, that's definitely where the UI and generative UI and all of these things probably have a big opportunity to change the way we interact with machines. Definitely a different talk. Thank you.
Well, thank you very much, Ruben. Another round of applause.